Hey guys, hope the special exam went well today. This is my first peek at the exam, and I'm going to attempt to provide my possible solutions. They may not be the full answers, as I'll probably be rushing this quite a lot, so let me know if there are any mistakes which come up. Alright, so first question, we have a polynomial, we have some complex number, and we want to factorize this, okay? So from what I can see, this here looks like it can be factorized into like z plus 3i squared and then something on the end here. So if we expand this z plus 3i squared, that's z squared plus 6iz plus 9i squared. The 9i squared just becomes negative 9. So if we want to factorize this and we want to get to 25, we have to subtract an extra 16 on top, right? So that means pz is just equal to z plus 3i squared minus 16. And that's the form that we want, I think. Yep, so that's fine. Okay, so now we have to solve p of z is equal to 0. So we just go this here. We can bring the 16 to the other side and then square root. So it's square root. Then on the right hand side we'll get plus or minus 4. So we get z is equal to negative 3i plus or minus 4. Or if you want to rewrite it in a nicer way, we can go 4 minus 3i or negative 4 minus 3i. If you want to be nicer in terms of the complex form. Okay, so that's that. Alright, question 2, solve the DE here. Okay, so it looks like it's a separable equation. We can bring this guy over, and we can bring this dx over here as well. So we're going to get 1 over square root of 4 minus y squared. In fact, we'll bring the negative over, because I can see that this here is going to become arc cos when we integrate. And then this here is going to become x dx. We'll integrate. Okay. So there are two general ways we could go about it. We could either just integrate it right now and we'll get a plus c and we can solve for plus c, or we could use definite integrals. I think definite integrals will be a bit easier here, so I'm going to do that. Right. So we have this initial condition here. That means that initially x is equal to 2 and initially y is equal to 0. Alright, and we just replace the top terminals with x and y. Now, if you're using definite integrals, what that means is you have to replace this here with a dummy variable. Same with here. So dummy variable means we can just change it to whatever we want, but just not y or x. So I'm just using k here, and for this one I'll just use t. Right, let's integrate. This here, if we integrate this, we're going to get, looks like it's going to be cos inverse of k over 2. And for this one, it looks like we're going to get a half t squared, like that. All right, let's sub in the numbers. We get cosine inverse of y over 2 minus cosine inverse of 0 is equal to a half x squared minus a half 2 squared, like that. Cos inverse of 0, the corresponding angle is just pi on 2. And for this here, we're going to get a half x squared minus a half times 4, which is 2. Right, so we get cosine inverse of y over 2 is equal to a half x squared minus 2 plus pi over 2. And so if we get rid of the cosine, if we cos both sides, we're going to get cos of a half x squared minus 2 plus pi on 2 is equal to y on 2. And if we solve for y, we get y is equal to 2 cosine of a half x squared minus 2 plus pi over 2. Is that what we wanted? We wanted our answer in the form y is equal to f of x. Alright, so that's fine. Okay, so that's that question there. Question 3, another stats question. varies normally with mean of 10 and standard deviation of 5. Find the probability that more than 34 seconds is needed to dispense a total of 4 cups of coffee. Okay, and we need to give our answer to 2 decimal places. Alright, so if we want to find the mean of this distribution, right? Let's say we want to find the mean and standard deviation of, the amount of coffee dispensed by 4 cups. Then we just do this. But this time, it's not, we don't put the, we don't multiply the 4 out in the front, we have to split it. Like this. Okay? Now if we split it, it's going to be like this. It's going to be e of x1 plus e of x2 ... Okay, it's going to be like that. So if we do that, we're going to get 10 plus 10 plus 10 plus 10, which is going to be 40. Okay? Now, if we want to find the standard deviation, I think the best way to start is just go by the variance first. Okay, we'll find the variance first, and then we'll go from there. So if we want to find the variance, we just have to add the individual variances of all of these, similar to the mean. Okay, so it'll be var x1 plus var x2 plus var x3 and then plus var x4. Now the variance is just going to be 1.5 squared. And so we add these, it's like going 2.25 times 4. Okay, so that's what's going to happen, and we get 11. No, that's not 11. I know what I'm talking about. That's 9. Yeah, okay, so this is 9. And so the standard deviation is quite nice. Okay, so that's what we know about this distribution. It's got a mean of 40 and a standard deviation of 3. So if we find the probability that x1 plus x2 plus x3 plus x4 is greater than 34, that there is just the same as the probability. We can convert this to a Z distribution. So it's the same as saying, remember the Z distribution is given by this. Okay. So this is here is the same as 34 minus 40 over 3. Which is negative 6 over 3, which is negative 2. So we're finding Z being greater than negative 2. Did I give you any critical values here? Because you need to remember that this question means you have to memorize your values. No, they don't. I don't think so. Wow. So okay, you need to actually memorize your values, your critical values for 1, 2, and 3 standard deviations. So if you remember, 1 standard deviation, the value is 66%. 2 standard deviations is 95%. And then 3 standard deviations is 99%. I think that was what it was. No, I think this is 68%. And the one we want is obviously this one, because that's what it represents. And if you draw this on the diagram, the 95% is going to look like this. Yeah, okay, and this is like negative 2, this is 2, and this is a mean of 0, like that. And what we want is we want to find we want to find this area here, right? So how do we do that from this original area? Well, we just need to find the area of this area, which we have, and then plus on a little bit of an extra one. Wow. I'm very surprised I don't give you this critical value here. Because what's going to happen here is this thing here is going to be 95 plus a half of 0.05. So if I were to highlight it, this area is going to be 95, 0.95, and then this area here, well, that's going to be 0.05 over 2. Oh no, that's fine. Okay, we can work with that. So we get 0.025. Okay, so if we do this here, we're going to get 0.95 plus 0.025, which in reality is 0.975. But we want to round to 2 decimal places, right? So this is approximately, this here is approximately 0.98. I'm not sure if that's right. The exact values are not, it's a bit pedantic. Anyway, the machine is to be served. After it's serviced, find the 95% confidence interval. Okay, so let's find the mean and the standard deviation. So the mean of this sample here, the mean time will be reduced. Okay, so the mean time we're told is 9 seconds. The standard deviation will remain the same. So if we want to find the standard deviation of the sample mean, we take the original standard deviation, which is 1.5, over the square root of n, which is 1.5 divided by 5, which you can rewrite as 3 over 10. Alright, so that means a 95% CI is given by it's given by 9 minus 1.96 times 3 over 10. And then 9 plus 1.96 times 3 over 10. That's what seems to be useful. Maybe it's worthwhile writing this as 0.3, since we're dealing with decimals. Right, so we get 9 minus, wow, 1.96 times 0.3. Okay, so it's 588. So we get 0.588. Like that. That should be right. Right, so if we round this, we're going to get 0.4. Oh, it's going to be 8.412, which is approximately 8.4. Because we have to round to 1 decimal place. For this one here, we're going to get 9.6 if we round it like that. Okay, so that's how I'll do that there. Seems like it's reasonable. Okay. Integrate this thing here. Okay, so it's partial fractions. This here is a cubic. And this here is a quadratic. So that means we don't do long division first. Okay, we can just split it up as usual. So if we split it up, if we split this up here, notice that we've got an irreducible quadratic. So the form is going to look something like this. A over x plus bx plus c over x squared plus 4. This is irreducible. That's why we put it in that form there. Okay, so we have to go ahead and find these values of a, b, and c. So we can multiply all these terms through. Alright, so we've got this here. So maybe what we could do is, if we want to find what a is here, we could get rid of this term here by subbing x is equal to 0. So we can do that. Right, so that means the left hand side becomes just 12, and the right hand side here becomes 0 plus 4, 4a, and so we get a is equal to 3. That seems reasonable, and of course this thing disappears as well. That's why I didn't say too much. This 0 just makes this whole thing disappear. So what else could we try? We could try okay, the next bit's going to be annoying. We could try maybe x is equal to 1 or something. Yeah, we'll try that. And we might have to solve some simultaneous equations too. So we're going to get, on the right, we're going to get 7 plus 12, which we get 19. For this here, let's use our value of a that we found. And that's 3 times 5, which is 15. And then plus b plus c times 1, so that just disappears. Alright, so that's clearly not enough. We need to do some other stuff. So perhaps what we could do is we could try subbing in. I think -1 would be nice. Let's try that. Okay, if we sub in -1, this here becomes positive. So it's going to be 3 plus 12, 15, minus 4. That becomes 11. And then this side here becomes 5 times 3, because this thing becomes positive, so we get 15 as well. And then plus negative b plus c times -1. Okay, so we get negative b plus c times -1, so this becomes 11 plus 15. Plus b minus c, by the looks of it. Yeah, so we can call this equation 1 and equation 2. If we want to solve, perhaps let's add them. We get 30 is equal to 30 plus 2b. So actually b is equal to 0. Alright, sub into 2. So we get 11 is equal to 15 plus 0 minus c, and so c is equal to 4. Yeah, okay, so what that means is that this whole thing here, it just becomes, according to what we found a is equal to 3, we found these here. So we are going to get 3 over x plus 4 over x squared plus 4 dx. Like that. I'm just going to do a quick check just to see if this works out. So we get 3x squared plus 4 plus 4x over x times x squared plus 4. And so we get 3x squared plus 4x plus 12 over x times x squared plus 4. Yep, cool, that's fine. Okay, so this looks fairly easy to integrate. This here is just going to become a natural log. Like that. And then this here, it's going to become tan inverse. So in actual fact, remember that tan inverse goes like this. That there becomes tan inverse of x over a. So this 4 is actually a little bit misleading. So what we need to do instead is we need to bring out a 2. So this here is the same as 2 times 2 on x squared plus 4 dx. That's what that bit is. So if we do that, it becomes 2 times tan inverse of x over 2 plus c. Okay, that seems fine. Yep. Okay, let's move on. Question 5. A body slides on a smooth plane. It's inclined where tan theta is equal to pi and 3. Find the speed of the body after 2 seconds. So maybe let's label in some forces. So this here is 10g. So this here is 10g cos of tan inverse of 1 over 3. In actual fact, sorry, this is not cos, this is sine. Okay, if we evaluate sine of tan inverse of 1 and 3, then basically it's this triangle here where we have the opposite being equal to 1 and the adjacent being equal to 3. So this side is root 10. So that means this here is just 10g. Well, sine of tan of 1/3 is going to be opposite over hypotenuse, which is 1 on 10. 1 on root 10. Which is just root 10g. Okay. So we have to find the speed of the body. This here is just the it's just the force downwards. So in fact we'll define positive acceleration down the plane. Okay, so that's what we're going to do first. Now we know that this is the force, root 10g. The guy is a mass of 10. And his acceleration we don't know, we want to find that. So his acceleration is just going to be root 10g over 10, which is, no, we can just leave it like that. Okay, that's acceleration, by the looks of things. Yeah, okay, so if we want to find the speed, we can use suvat. So we're given time, given acceleration, and we know what the initial velocity is because we're told it's initially at rest, right? So we know what v, or we want to find v, we know that u is 0, we know that t is 2, and we know that acceleration is root this on that. So what we're going to do here is, therefore, we can use this equation. We can use v is equal to u plus at. So we get 0 plus root 10g on 10 times 2. And so the speed looks like it's going to be 2 root 10 over 10g. Yeah, okay, that looks fine, I think. Okay, yep. Nice. Okay, so after the body's been in motion for 2 seconds, a constant braking force, R newtons, is applied to the body parallel to the plane, such that the body has constant velocity. Find the value of R. So constant velocity, first of all, this means that acceleration is equal to 0. Okay, which means that F is equal to 0 as well. Right? So what's the situation? No, sorry, it's tan inverse of 1 and 3. The situation here is we've got a block. This force this way is 10g. Sorry, it is root 10g. That force is root 10g. And so what that means is we've only got this force going down, so we need an extra force to balance this out. So this is that force, and if we apply an R force, these forces have to be the same. Okay, so it just means that those forces there are the same. So overall, we're going to get R is equal to root 10g newtons. Okay, very straightforward. The 1 mark also kind of gives it away. I'm just quickly going to double check this as well. Yeah, okay, it seems fine. That's pretty straightforward. Okay, cool. Find the cosine of the acute angle between these things. So if we want to find the angle, we just dot product. We remember that dot product is equal to magnitude of A times magnitude of B, cosine theta. Theta here is the angle. So if we want to find cosine theta, it's just A dot B over mod A mod B. So if we want to dot product these things here, we're going to get 2 times 1, which is 2. This here minus times 2 is negative 6, and then this here becomes positive 12. And then the magnitude of A is going to be square root of 4 plus 3 squared, which is 9, and then 36. And then mod B is going to be 1 plus 4 plus 4. Okay, so we get cosine theta is equal to 14 minus 6 is 8. This here adds to become 49, which is 7. And then this here adds to become 9, which is 3. Okay, so we're going to get 8 over 21 as your cosine of the angle. Alright, and we want to find the cosine of the acute angle. So be careful, we're not finding the angle, we're just finding the cosine of the angle. Okay, we have a semicircle, express, okay, wow. Okay, express the vectors OP and QP in terms of A, X, Y, I, J. Alright, so OP here, OP is clearly going to be, it's just going to be xi plus yj, fairly straightforward. And then QP here, well, if you look at what Q is, Q has the coordinates 2a, 0. Okay, that's just by looking at the diagram here. So if you were to find QP, it's basically like the vector OP. Or it's this here minus this. Like that. So it's just this vector here minus this vector. That will get you that. Okay, so if we combine these, we're going to get x minus 2a I plus yj. And that appears like it's right. Okay, using the vector scalar product, determine whether OP is perpendicular to QP. Now, an important thing to note is if they're a semicircle, we actually expect that they will be perpendicular. So this is vector proof's question. We expect these to be perpendicular. Okay? So that's just a mental note you should make to yourself, because what you may have learned in vector proof is if you have a circle and you have the diameter of a circle, then the angle subtended by these, this angle here is going to be a right angle. Okay? That's just what we expect, but we'll see if that works out. So we just go OP dot QP is equal to x times x minus 2a plus y squared. Okay, that's interesting. So we get x squared minus 2ax plus y squared. How do we deal with this? Is there something here that helps us? Alright, we have a semicircle equation here. We could use that. Perhaps. So what is it? Root a squared minus x minus a squared. Alright, so we get x squared minus 2ax plus the square root just disappears, so we're going to get a squared minus x minus a squared. We may as well expand that, so we're going to get x squared minus 2ax plus a squared. Like that. Alright, so if we look at some of the terms here, this and this is going to cancel. This and this is going to cancel. And then this here makes a plus, so plus 2ax minus 2ax, they also cancel. So we're actually going to get 0. So what does that mean? That means if the dot product is 0, we say that OP and QP are perpendicular. Okay, very interesting question, but ultimately very straightforward. Okay, so we actually expect these to be perpendicular. That's how you can kind of work on that question there. All right. Okay, so another gradient question. So we can find the derivative of this. We can use implicit differentiation. Right, if we differentiate this, we're going to get, looks like it's going to be the product rule. So it will be x dashed cosine of x plus y plus x times cosine x plus y dashed. And this here just becomes 0. So we're going to get cosine of x plus y plus x times the derivative remember, if we were to derive a cosine function, it switches to negative sign. And we also bring this thing out the front here. We bring the derivative out the front by the chain rule. So we're going to get x plus y dashed times negative sine of x plus y. That's what's going to happen. Okay. Bit stingy with the brackets, but that's probably how you should set it out. Right, so if we do that, we get cosine x plus y. If we differentiate this here, we're going to get 1 plus dy and dx. Actually, we'll bring the negative sine x plus y out to the front as well. Like that. Alright, and then we're going to get multiplied by 1 plus dy on dx if we differentiate that. That's what it looks like to me. Yep, okay. So if we want to solve for dy and dx, we can do that. We can just... What I've done is you can bring this over to the other side and you can divide this. So we're going to get... we're going to get 1 plus dy and dx is equal to cos x plus y over x sine x plus y. Okay, so dy on dx is equal to cos x plus y x sine x plus y minus 1. So at what was the coordinates? We needed to find pi on 24 and 7 pi on 24, and we want to find the gradient. Okay, not the normal. Sometimes it asks for the normal. Alright, so if we were to sub in this point, we get dy on dx is equal to cosine of pi on 24 plus 7 pi on 24, 8 pi on 24, which is just pi over 3, times pi on 24 times sine of pi on 3 as well. Alright, so what happens there is we're going to get cosine of pi on 3, that's that's a half. Then sine pi on 3 is root 3 over 2. Alright, what form? A root b minus pi over pi. Alright, so perhaps we could multiply this whole fraction by 2. Okay, if we do that, the 2 here cancels, so we get 1 on top. And the bottom here, it's just going to become root 3 pi over 24, because these 2's will cancel. Minus 1. And if we flip the fraction over, we can get 24 over root 3 pi minus 1. Is that in the form yet? It's not. So we want to just obtain pi in the bottom. So we're going to get 24 root 3 on 3 pi minus, let's just chuck this over, no, we will leave it for now. This here cancels, so we get 8 root 3 over pi, yep. And then this we can turn into pi over pi, so overall this becomes 8 root 3 minus pi over pi. Okay, that looks reasonable. Good. Alright, so that's the answer for question 7. Gee, that was a lot of work. Okay, question 8. A body moves in a straight line. Find v in terms of x. For this interval. Okay, so we have acceleration is equal to negative 4x if we want to find v in terms of x, we have to go v dv dx is equal to negative 4x. And of course we can just integrate this. So what are we told? We're told the body accelerates from rest and its velocity is equal to negative 2 meters per second as it passes through the origin. The body then comes to rest again. Alright, so what this means here, this means that v is equal to negative 2 and x is equal to 0. That's one condition. This here doesn't tell us anything because we don't know anything about t. And if we have one initial condition, it makes sense that we can just use that initial condition and then find v in terms of x. So we're just going to sub that in. So we're going to get negative 2 and then 0. That was the initial condition. And we can put v and x on top. Now once again, we're going to have to replace all of these with dummy variables too. Like that. Okay, so that's how I would go about that there. So we're going to get a half k squared v negative 2 and then negative 2t squared 0x. And so we're going to get a half v squared minus a half times 4, which is 2. And then we're going to get negative 2x squared. If you sub in 0, we get 0, so that's fine. Alright, so that's what we get. Okay. So we want to find v in terms of x, so we have to solve for v. So we get a half v squared is equal to negative 2x squared plus 2. We can multiply the 2 through, and so we get v squared is equal to 4x squared plus 4. Okay. And so if we want to find v, it's plus or minus the square root of this. But what do we know? We know that v is negative. So what does that mean? It means we take negative root, right? So what that means there is we get negative this here. What we could do as well is we could take this 2 out. We could take the factor of 4 out and we get 2. So we're going to get negative 2 of 1 minus x squared. Yep, okay, that's fine. Alright, given that f dashed, find f of x. Okay, so if we want to find f of x, we just integrate this. There's a lot of integration questions on this paper. Right, and we could either choose to sub in the initial condition now, or we could do it later. In this sense, maybe it would be neater to sub it in later. I think it's better to focus on just trying to integrate this thing first. So if we want to integrate this, we could break this sign here into sine of 2x and then we could break it also into 1 minus cos squared of 2x. I'm not sure if that helps. It might. No, I don't think it helps that much. I don't believe so. So how are we going to do this here? It could be a U sub question. Yeah, okay, so I don't think it's probably not helpful to split up this here. It doesn't help here simply because it's a fraction. So if I were to notice anything, we could try U sub. So maybe we let U equal to the bottom fraction, the bottom part. So U is equal to sine 2x. If we differentiate this here, we're going to get 2 cosine of 2x. And so we get du is equal to 2 cos x, 2x dx. And so now this can be simplified here. So we're going to get f of x is equal to the integral of u cubed. This here we can do if we add an extra 2 here, but that means we have to multiply by a half. Okay, so that's how we do that there. Okay, in other words, we could do it like this as well. We could go a half du is equal to cosine 2x dx. That works as well. Alright, so that's fine. Okay, so we're going to get here that it is, if we integrate this, is very simple. We get negative a quarter u squared plus c. I'll check that again. If you the full u should be on the bottom. If we differentiate this, we get the power reducing and the negative 2 comes out the front, which makes a half. Yeah, that's fine. And we replace this with our condition, which was sine 2x, or sine squared 2x plus c. Okay, and what's the initial condition? Well, we know that f of pi on 8 is equal to 3 and 4. So if we sub in pi on 8 here, we're going to get negative a quarter sine squared of pi on 4 plus c is equal to 3 pi on 8. Sorry, not 3, it's 3 quarters. Sine of pi on 4 is 1 on root 2. So it becomes a half if you square root it. So just write a note here. So if we square it, we get a half. A half cancels with the 4 and we get negative a half. And so ultimately, we're going to get c is equal to a half plus 3 quarters, which is 5 quarters. And so therefore, what does that mean about the function? It means the function here is equal to negative 1 on 4 sine squared 2x plus 5 on 4. Does that look reasonable? Yes, I think it's fine. It should be okay. Yeah, okay, that's all good. All right, sketch secant. What's the next question? Solid of revolution. So if we want to do this, okay, so clearly, if we have x is equal to pi on 4, so the period of secant or if we think about the normal secant graph, then if we're subbing in negative pi and 4, we're essentially subbing in secant of pi. Secant is 1 on cos, and this is not allowed. No, sorry. This is okay. Secant of negative pi is cos of negative 1 on cos of negative pi, which is negative 1, and secant of pi is also negative 1. So that's okay. Okay, so maybe we want to label in the we might want to label in the endpoints here. So at negative pi and 4, it's negative 1. And at pi and 4, it's also negative 1, like that. Note that secant of pi over 2, that there is not defined because we're not allowed to have cosine of pi and 2 is equal to 0, simply because it makes the fraction undefined. Same with secant of negative pi and 2, that's also doesn't work. So that means the asymptotes here are going to be these ones here. Okay, these are going to be the asymptotes. Okay, and another thing we could do here is we could try and sub in 0. So secant of 0 that's 1 over cosine of 0, which is 1. So that there is our point, 0, 1. Alright, so if we were to sketch this, the sketch looks something like this. Okay, that's what the secant graph will look like, I believe. Okay. The graph is rotated to form a solid of revolution. Find the volume of the solid. Okay, so if we were to find the volume, first of all, it's rotated around the x-axis, and we want to find it in this form. Alright, so if we want to find the volume, it's just pi times the integral from negative pi and 24 to pi and 48. Let's just double check to see if this works. So if we were to find it, it's like here to here, maybe? Yep, that works within the context of the question. And so we want to integrate, what was the function? Secant of 4x. Like that. Okay. Now integrating secant, this here, okay, no, we would have square it. Sorry, we have to square the function because that's what we're doing there, right? So if we integrate secant squared, that's very straightforward as it just goes directly to tan. So it becomes a quarter tan of 4x. Okay, this here is pretty straightforward. Okay, so if we sum the numbers, we get a quarter tan of pi on 48. 4 times pi on 48 is pi on 12. Oh, that's a bit annoying. Alright, and if we do this, next one, we get tan of 4 times pi on 24 is negative pi on 6. Okay, that one's nicer. Maybe let's take the quarter out as well. And we'll do this. Okay, so the next thing we need to do is we need to find what tan of pi on 12 is, which is a bit annoying, but we can do it. Okay, we can do it if we know that tan of pi on 6, which is 2 times pi on 12, is equal to, well, tan of pi on 6, that's root 3 on 3. We can split this up using a double angle formula, and then we can solve. So if we do double angle, we get 2 tan of pi on 12 on 1 minus tan squared of pi on 12 is equal to, we might leave this as 1 on root 3 as well. I think that's easier. if we go ahead and solve, let's move it up a bit. I think that would be nicer. All right, and let's get rid of this. All right, so if we were to solve this, we're going to get we're going to get this, right? And if we rearrange a bit, we get tan squared of pi on 12, or 1 on root 3 of it, plus 2 tan of pi on 12 minus 1 on root 3 is equal to 0. That's what it looks like anyway. So we're going to get tan of pi on 12. We'll use the quadratic formula. Negative b plus or minus b squared, which is 4, minus 4ac. Wow, this is annoying. Okay, hopefully you can see my writing here. Right, and this is all over 2a, which is 2 on root 3. Okay, so we're going to get, okay, this here becomes 4 on 3 if we multiply it. So negative 2 plus or minus root 4 plus 4 on 3, which is 13 over 3, I think. 4 on 3, no, sorry, it's 16 on 3. All over 2 root 3. So the top here actually becomes 4 on root 3. Cool, okay. Now another thing to notice as well is tan of pi on 12 is positive, so we only take the positive side, take positive solution. Okay, so we don't care about the plus or minus, alright? So therefore, tan of pi on 12 is going to be negative 2 plus 4 on root 3 on 2 root 3. If we multiply the root 3's through, we're going to get 4 minus 2 root 3 over 2, which is just 2 minus root 3, by the sounds of it. Yeah, okay, that's a bit annoying, but we have to do that. Okay, so if we do that there, we're going to get, we already took the a quarter out, so it just becomes tan of pi on 12, which is 2 minus root 3. Then tan of negative pi on 6, well, this here we can write as minus, and tan, and this is going to be negative, so we get negative root 3 over 3. Like that. Do we run a, yeah, okay, that's good. So let's put everything all over 3. So we're going to get 8, sorry. If we put everything all over 3, including these, we're going to get 6 minus 3 root 3 over 3 plus root 3 over 3. Like that. Alright, and if we do that, we're going to get, what's the form? Okay, it looks like that. So if we simplify a bit, we're going to get 6 minus 2 root 3 pi over 12, from what it seems. Yep, and this can be simplified a bit more, so we get 3 minus root 3 pi over 6. Okay, hopefully that's right. Hopefully I haven't stuffed up anything. But it looks like that's in the correct form there. Yeah, okay, I will trust this answer. It looks fine. Okay, let's check. We got this. Turning points and endpoints, yep. Yep, this looks fine. Does that form look fine? Yep. Yep. Yep, this is okay. That's okay as well. Alright. This was a bit nasty. Surprised. In future years, you need to remember to memorize your standard deviation values, these ones. Okay, you need to memorize them for the future. This is fine. This is fine as well. Okay, that exam was very reasonable. So overall, quite easy. Some nasty algebra as always. Lots of form writing, but otherwise I think it was doable. Hopefully you guys went okay. And best of luck for exam 2. See ya.